So students, now let's start a new activity, activity 5.1, area of a circle. So first, let us know about area of a circle. Area of a circle is the region occupied by the circle in two-dimensional space. In two-dimensional space. It can be calculated using the formula So, area can be calculated using the formula A equals to pi r square, where r is the radius of the circle. So we can say it has only area and circumference. And it does not have volume. So the area is the region occupied by that circle in two-dimensional space, so it does not have volume, as volume is considered in a three-dimensional space. So students, our objective for this activity is to give a suggestive demonstration of the formula that the area of the circle is half the product of its circumference and radius. That the area of the circle is half the product of its circumference and radius, A by coiling method and B by paper cutting method. So now let's see the procedure for the given activity by coiling method. Step 1. Draw a circle of radius r on a cardboard. Step 2. Cut the colored threads of various sizes. Suppose this is our circle of radius r, that is, its radius is r. Now step 3. Now fill up the circle by pasting colored threads of various sizes in concentric pattern. Various sizes in concentric pattern. And we must arrange these threads in such a way that there is no gap left between the threads. Suppose our first thread is Now let's remove R. So this is our first thread. Let's mark it. Now the second thread. So in the way we are putting, this is called the concentric way. That is focused towards the center. That is, every circle will have the same center. Now in this way we have placed our second thread. Now third thread. Now fourth thread. Similarly fifth thread. Now these threads should be of in this way we have arranged the thread such that there is no gap left between the threads. So in this way, this is the concentric way to arrange the threads. So the threads at the outermost layer will be the bigger thread, then we have a smaller thread, then again a thread of different color. In this way we have filled up the complete circle by placing the threads of different sizes in a concentric pattern. Arrange the other set of colored thread starting from the smallest. So now we arrange the colored threads. So this is our first thread. Then second. Such that the last thread, that is the last thread, is of the same color and size as that of the outermost thread. Of circle. So, such that the height of these threads, that is H, is equal to R, that is the radius R. So we can say the last thread finds the circumference, that is 2 pi R. So the last and the outermost thread defines the circumference of the circle, that is 2 pi R. So students, now let's see the procedure for this activity using our second method, that is the paper cutting method. So step 1, draw a circle of radius R. On a sheet of paper. Step 2, fold the circle along one of its diameter. Suppose this is the circle of radius r. Now we fold the circle along its diameter. Now fold the circle along its diameter to get two semicircles. This is the center of the circle O, and diameter is AB. We get two semicircles. Step 3. We again fold the semicircles to obtain quarters of the circle. In this way, we have formed quarters of the semicircle. That is, we have folded the semicircle along the radius such that B is exactly comes over point A. That is, point B is exactly over point A. So in such way, we will fold the semicircles to obtain our quarters. Now, the similar way, repeat the same process of folding 2 times more. That is, we again fold the quarters along the center O such that they are divided into equal halves. Then again follow the same process and divide them into 2 equal. Step 5. After folding the paper 2 more times, unfold circle. We see that the circle is divided into 16 small sectors, equal small sectors. That is, when we unfold the paper, we see that our circle has been divided into 16 equal small sectors. This way, our circle has been divided into 16 small sectors. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and at last 16. So the 16 sectors have been formed by paper folding, and these sectors are equal sectors. Now step 6. Now color the 8 sectors on one side with one color and the remaining 8 with different color or with another color. Such that we shade these sectors with one color and the remaining 8 sectors with different color. Now step 7, cut off and separate the various small sectors of the circle. Now step 8, cut off one of the small non-colored sector into 2 equal parts. That is, we take a non-colored sector. Suppose we take sector 16 and divide it into 2 equal halves. Now step 9, arrange these sectors. That is, now we have 15 plus 2, 17 sectors. Arrange these 15 plus 2 sectors to form a rectangular shape. So suppose we are arranging the sectors in a way that at the ends we are placing these 2 sectors, that is, the sectors we have put into 2 halves. Then a colored sector, then a non-colored sector, then again colored sector, that is 2 colored sector, 1 non-colored sector and 1 half non-colored sector. Now again a colored non-colored sector, then a colored sector, then a non-colored, then colored, then non-colored, and then again colored sector, then a non-colored sector, then a colored sector, then non-colored sector, then a colored sector, then a non-colored sector, and at last the 8th colored sector, and 1 half non-colored sector. That is, for this reason we have converted one non-colored sector into 2 equal halves so that we can place at the ends and form a rectangular shape. So now you can count, there are 17 sectors, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. That is 15 complete sectors and 2 half sectors. So now let's see the observations for the given activity. First let's see observation for part A, that is by calling method. So our first observation is the triangle we have formed. So the base of that triangle is 2 pi r. Second, height of the triangle is equal to h, that is equal to r, radius. Third, area of triangle is equal to half into base into height equals to half into base is 2 pi r into r. So we get equals to pi r square, which is equal to area of the circle. So in this way, by calling method, we have proved that area of the circle is pi r square. So now let's see observation by our second method, the paper cutting method. First, when we arrange, we see that the arrangement of sectors forms a rectangular shape, where the length of the rectangle is equal to half the circumference of the circle. And breadth is equal to radius of the circle. Step 3. Area of rectangle equals to length into breadth equals to half of the circumference of circle into breadth is radius of the circle. Now half of the circumference is equal to 1 by 2 into circumference is 2 pi r into radius is r, so it is equal to pi r square, which is equal to area of the circle. In this way, we have proved that area of circle is half the circumference of the circle multiplied by radius of the circle, or we can say The product of half of the circumference of the circle and radius of the circle is equal to area of the circle.